So, first problem says, we wish to determine if the average income of all criminal law attorneys in Colorado. We randomly sample 500. We randomly sample 500 lawyers from a database kept by the Colorado state government. For those 500 attorneys, we calculate the average salary is $42,000 per year with a standard deviation of 14,000. All right. So, I don't know, that seems a little low for a lawyer. All right. So they told us it was randomly selected. That's good. Correct? So that's the thing. And we're only looking for Colorado. Okay? So if we wish to determine the average income of all criminal law attorneys in Colorado, and we randomly sample 500 criminal law attorneys from the database kept by the Colorado state government. Okay? So this seems pretty good. This is a good number. This is our N value. Our sample is great. Okay? So we I did. She did. We got it. All right. Sorry. So our population mean. Versus our sample mean. Oh, it already did it to me. Can't win with this. Sky, where's your book?
I don't have $5, and they don't take American Express.
Still?
No.
Oh. You have this page, though. I gave you this page yesterday.
Do you want me to get it out?
Fine.
Okay, I guess.
Oh my gosh, my stuff. Why is it not working? All right. So, if we wanted to find our population mean versus our sample mean. Okay. All right. Our sample mean is the 42,000. Our population standard deviation. And our sample standard deviation. We know our sample standard deviation and we know our sample mean. We don't know. Hello. We're on page 73. So we don't know these. Okay? So in a sentence, describe the estimate we are attempting to make here. We're trying to figure out, for number 5, we're trying to figure out what the average criminal law attorney in Colorado makes. Okay? So we know the sample mean, we know the sample standard deviation. We don't know the population mean or the population standard deviation. Okay? Do we trust the sample to represent the population? Why or why not? Okay. So, number 6, it's random. We want Colorado. We got our data from a Colorado database, randomly. Okay? So we could trust this. Okay? They said it was a random sample from the database of 500 people. 500 is a really good number. What we would start getting to is basically our sample size. If it is 30 or greater, we're going to start trusting it. Okay, as long as it came random. All right, so we know that. That's the first part. Then we can move down. It says IQ tests are written and scored in such a way that you have a mean universally of 100 and a standard deviation of 15. Okay? And then they say a group of 1,000 psychology students at Northern Colorado take an IQ test. And so then they find that they have a mean of this and a standard deviation of this. All right. So this is known by the population. This is the population mean. This is the population standard deviation. This is our sample mean and our sample standard deviation. Okay? All right. So we have everything. That's 7, 8, 9 right there. So population, sample, or population mean, sample mean, population standard deviation, sample standard deviation. Those are those numbers. All right. In a sentence, describe the estimate we are attempting to make here. So in a sentence, we're attempting to say, is the 104, so I guess this is 11, is 104 close enough to the 100? Okay? I don't know. It might be. But I will tell you, do we trust this? It wasn't random. And it was taken, and it was done locally. Okay? Those are two bad things. Okay? These are two bad things. So we're not going to trust it. I mean, it's fine if we did this. It's like, hey, we showed this, and look at how you go up against the nation. That's fine. Okay? But I would not put gospel truth in it. Okay? Backside 74 says the mean height of adult men in the United States is 69 inches. Okay, so population mean is 69 inches. And then the population standard deviation is 2.5. Come on. And then they said a random sample of 8 men at a local shopping mall. So this is my sample. We had 8 men at a local shopping. Okay. So they find that these men have an average height of 67 inches and they have a standard deviation. So sample mean, sample standard deviation is 2.1. Okay. In a sentence, describe what we're attempting to do here. So 17 is 67 inches close enough quick change of colors. Is that close enough to the 69 inches? Okay. 18, do we trust this? We have a sample of 8. That's too low. And it's a local mall. So both these things are big red flags. Okay, we don't have a big enough sample. It does say it was a random sample, but the sample's not big enough. So I like the random sample. And I don't know how they did randomness finding these 8 people, but they said it was random. So the random is fine, but we have such a small sample, I don't know if I trust it. And then we're at a local mall, and we're trying to apply that local mall sample to the nation. Okay. 19, what's the difference between a statistics and a parameter? A statistic is something that we know overall. A parameter is something that we're trying to think that we're going to approach. So the sample mean is not always known, but we kind of know based on our discovery of doing a random stratified sample of an entire population, we kind of know where we're going to regress close to, but we're not sure. So the parameter is kind of our unknown.
Okay.
We wish to take a random sample of students at CCHS. Which method provided in the sample could we trust to represent the population? Explain briefly. Okay, so A, we go into the Creek Cafe during 5th and 6th period and ask students sitting inside. Well, 20A, it's not a random sample. It's a local, it's isolating the cafe. We know that not everyone at school is going to go in the cafe, and we also know that we're not including 4th period, so none of those things are good. We select 4 English classes at random and ask all the students in those classes. So 4 English classes, if we're just applying to Cherry Creek High School, I would say almost our entire population is taking English, so each English class would have a random chance of being selected. So that might be good if we're applying something to the rest of the population of Cherry Creek High School. We could not apply that to all high schools, though. And then we put the name of every Cherry Creek's name in a hat. And then we pull out 50 names and ask those chosen students. Okay. C is a really good thing. If you were to put names in a hat and shuffle over, mix them all around and select 50 out, and honestly, if you select those 50, you grab one, take it out, shake it up, grab another, take it out, shake it up, take another, take it out, and keep going with that process. That is a good way of randomly sampling. All students' name in the hat. I mean, that's a pretty good method to go about doing this kind of stuff. Okay? And that is how the homework went. Any questions on that? We good in the hood? Okay.
Watching some drag racing, street racing.
Sweet. Page 5. All right. So I have a question for you. So let's talk about the red bag of Skittles. Red Skittles. Okay. How many different colors of Skittles are there in the red bag?
Red, green, yellow,
Green,
orange,
yellow.
black.
Red, green, yellow, orange, purple.
Am I missing one?
I don't know.
No, I think that's right.
Okay.
That's totally right.
Yellow.
I said-
Yellow, got it. Yellow right there.
Did I say that?
Yep, you got it. Red, green,
I don't-
orange.
What's your favorite Skittle?
Yellow.
Yeah. All right. So
Sir, what's your favorite Skittle?
I usually just do the handful.
Oh, interesting. Personally, I'm a red
Who's that?
unless the green is lime.
Yes.
When he comes back in, we gotta ask him what he did.
Yeah, no kidding. We'll get the story.
I don't think he's coming back. Yeah, actually, let's think about that.
Hey,
He's
Jimmy's
not coming
over
back.
there. The fact that this is really sad.
All right. Hey, so those are my colors, according to us, of the red bag of Skittles. Do you feel comfortable with that? So I have a question for you. So let's say each one of these is 20%. Okay? Let's say they have an equal distribution of all of those Skittles. Agree? If you were to went to the store and you got yourself a bag of Skittles and they were all orange, would that kind of be like, oh, cool? Would that kind of capture your attention? If you knew that the Skittles of a red bags of Skittles are supposed to be evenly distributed, meaning you have 20% red, 20% green, 20% yellow, 20% orange, 20% purple. And if you went to over to the store and you bought yourself a thing of Skittles, you open it up, and you look in your bag and you're like, dude, these are all orange. So you pull them out in your hand and you're like, oh my gosh, I have all orange Skittles in this bag. Does that seem like it would be kind of awkward? Seems a little different, right? Okay, but in your opinion, do you think this event could happen? Theoretically, could it? Maybe by accident? Maybe? So, yeah, very slim chance, but there's a chance. So we're going with a maybe. Agree? Seem okay? So these types of things happen. Now let's say we did this. Let's say we were rolling dice. Rolling dice. Okay? So if you roll dice, you add the top values. So you can get 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay? Those are the values you can get when you roll a pair of dice. Agree? Now, the most likely number to come up is a 7. Okay? This is a 6 out of 36 chance. An 8 is a 5 out of 36. A 6 is a 5 out of 36. A 9 is a 4 out of 36. A 5 is a 4 out of 36. A 10 is a 3 out of 36. A 4 is a 3 out of 36. An 11 is a 2 out of 36. A 12 is a 1 out of 36. A 3 is a 2 out of 36. And a 2 is a 1 out of 36. So those are the probabilities that any of those types of numbers would come up if we were rolling dice. So the most likely number to show up would be a 7. Okay? So let's say you were rolling dice and you would record what value you were getting each time. So let's say you rolled the dice 10 times. And let's say you got a 7, a 7, a 7, a 7, a 7, an 8, a 7, 1, 2, 3, 4, 5, 6, 7, 4, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, and a 10. So let's say you were rolling dice, you roll the dice 10 times and you happen to get that type of situation. Now it didn't have to be in that order. This could have been mixed up in any order. Would it shock you that the 7 is happening more often than the rest of the dice? Has the highest probability. So do you think that this could happen? Yeah. And it's not too unlikely. Now, let's say I was rolling 10 dice again and I wound up getting this. 7, 8, 9, 10. Let's say I rolled dice and whatever order it was, those came up. Would you think the black event would be a likely event? I mean, I like the 7 showing up, but a 2 is a 1 in 36 chance. So it's basically 1 in 36 times 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 4 in 36 times 5 in 36 times 6 out of 36 times 6 out of 36. The probability of that taking place is going to be pretty unlikely, especially because the 2's coming up. You can only get a 2 one way, a 1 and a 1 being on the top of each of the dice. Okay? So I want us to kind of think about how that might take place. All right, so on page 5, it says, when characteristic of a population are known, the sample mean of any sampling distribution can be modeled with well-established formulas. So let's consider this idea. Okay, you have an IQ test, and they tell you that the population mean is 100. Now, the reason why you'd be able to get a population mean of an IQ test is there's an awful lot of IQ tests that have been done for a number of years, and you could sit there and say, we're getting really, really, really close to the parameter. Okay? Okay, meaning the 100 seems like what we're trying to regress the mean. Now, people would, if we were to sample some people randomly, it's possible people get above, right at, or below the mean. Okay, and then let's consider the population standard deviation of 15. Okay, so we've done this on decimals. Yes, we could draw ourselves a normal curve. So then we want to take a look. If we select 100 people, so random selection of 100 people, random people, and we will have the IQ be exactly 100. It's bouncing too much on me. Okay, so, and then, so it's very likely our random samples will produce different averages only because randomness produces different results. So the thing is, if we knew from hundreds of millions of IQ tests that this is what it's showing, so they're saying that we kind of know our parameter because we have hundreds of millions of these tests that we took the data from. We found the average and standard deviation. Would you feel comfortable if I randomly selected 100 of those people from that database that I would find that my sample mean would fall exactly at 100? Okay, so think about this. On a normal curve, we have 100 here, we have 115 here, and we have 85 here. So does anyone remember what percent of the population should fall between one standard deviation? Thinking back before Christmas, before when? 68, yeah. All right. So in theory, my friends, think about what you know about a normal curve. A normal curve, 68% of our population should fall within one standard deviation. So if I were to randomly select 100 IQ tests that have been done, for us to get exactly to the mean of 100 could be likely, but I also know that 68% of my population, 68% of my tests should fall between 85 and 115. Now, if I took the average of all those, should that be close? And the answer is yes. Okay? Because again, we're taking the average. Even though I'm getting scores down here and I'm getting scores up here, hopefully enough of them happen within that range that when I find the average mean or the sample mean, they approach that sample perimeter. We regress to the mean. Okay? So it could take place. But if I were to say, okay, I took that 100 random, I put all of those randomness factors back in, and then I did another selection of another 100 random. So it's very possible as I go through and keep doing 100 randomly selected people or tests, it's very possible because things are taking place, there is some variability that's taking place. Okay, and they say this: sampling variability is the tendency to produce different results from a random sample from random sample. Okay, so there's roughly 27 of us in this class right now. Okay, 27 is a pretty good sample population. If I randomly selected 10 people and did like shoe sizes, and then I put those 10 people back in the thing, and I randomly selected 10 more people, and then I put those people back into the thing, I randomly selected 10 more people, I put those people back in, there's a chance you might have gotten picked a number of times, okay, by randomness, okay? But by us doing that, if I were to take the whole census of the class, find the average shoe size, and then of everybody, and then I randomly selected 10 people and kept putting them back into the thing and kept randomly selecting 10 people, I'm going to start getting a little bit different results each time. Okay? If I do it an infinite amount of times, it will regress back to what our average is as for this population. Okay? So, middle of page 5 says, assume that a psychologist finds a random sample of 100 people, measures their IQs, assume the average sample is 102.2 and the standard deviation is 15.4. This sample differs. All right, so what I want to do is I want to look at Desmos real quick. And as soon as I get done with this, I'll be done. All right, so I'm going back to our roots. So I'm going to type in normal distribution. Okay, normal distribution. So I'm going to go based on our 100 and our 15. Hit the plus button so we can see our... So that's our normal distribution of our entire sample. But now we're going to say, hey, what would happen if I were to do the normal distribution on a second one, and this guy came up with 102.2 and 15.4. Okay, so just looking at the two normal distributions that we have, even though one of them we're showing a 102.2 as a mean, take a look at our two normal distributions. Do our two normal distributions, in your opinion, just by looking at it, think about the area underneath the curve on each of those normal distributions. Does the area of the red, does the majority of the area of the red and the majority of the area of the blue cover each other up pretty closely? What do you think? Does the area of the red and the area of the blue closely overlap each other in that? Does that make sense? So this is a very likely chance this to take place. There is a slight variability with our blue sample because it was off just a little tiny bit, but that's okay. If they were to do another one, and we were to take a look at it, and again, I'm just going to type in normal dist. Normal distribution, and we're going to go down a little bit further. They say a different psychologist found that he had a 99.3. Oops, delete. 99.3 and a standard deviation of 15.2. Well, now let's take a look at our green. Okay, so remember our red was our original, and then it changes a little bit from that. So if we start looking at this, does it appear that the majority of their areas are overlapping each other? I think so. Does it appear that some of them are slightly off? It appears that from the red to the blue, it's slightly to the right. From the red to the green, it's slightly left. Okay? So these characteristics, so that's sampling variability right there. Now, as long as when you're looking at the normal curve, and the normal curve is a really good visual representation, if it appears most of the area is overlapping, I think we're on to something. If they're way, way off, though it could happen, the chance of that happening becomes smaller and smaller. Okay? So we choose the characteristics of the group that collected samples. Now we need to introduce two new variables, the sample mean and the sample standard deviation. Okay, so I'm going to stop there for today. Okay, so I'm halfway down. But this is what we're going to start really looking at, is how likely are these events taking place? Do they fathom us enough to say yes or no? So I got halfway down page 5. I don't have homework for the weekend. Is that okay?
Yes.
Okay. So if any of you had missed the test the other day, I would like for you to consider coming in during access period on Wednesday, because I'll have kids from this period as well as 7th period. That way you can do the test together. If you don't come in during that time, then you're going to have to do the test on your own, so you need to come see me on an off period, okay?
No, it's not.